so today we are factoring polynomials. We factored before earlier this year, but now there's like we need to factor out a common factor first. So if I take a look at number 1, it wants me to factor it completely. Notice all 3 of these have what in common? An x. So I'm going to factor out an x from each of them. Put your phone away and take notes. I have a pen. Okay, so now I'm looking for what multiplies to -5 and adds to -4. Is you okay? Wait, did you say 4? Should be 1 and 5. Should be -5. We always multiply to the end number. That's it. That's the answer. Okay, so what can I take out of number 2? What? That's the answer. Or why did I do what? Split? Because that's what factoring is. It's breaking it down to all of the pieces that multiply to it. Okay. So what can I take out of number 2? How many? 3. Anything else that I can take out? Bless you. Bless you. Yes, what number? Do you know which number? 3. 3 divides both 3 and 48. So I'm going to write the 3y cubed out front. What's 3y to the 5th divided by 3y cubed? 3y to the 5th divided by 3y cubed. Y squared. -48y cubed divided by 3y cubed. 16. It's still negative. Okay. Do you guys remember what happens when I have a squared minus a perfect square? This is called a difference of squares. So, what's the square root of 16? 4. So I'm going to have one that's -4 and another one that's +4 for my factors. You don't think you understand? Okay. So basically, like, you know when we have like a number like 81 and we like factor tree it? That's kind of what we're doing here. We're breaking it down to all the factors. Okay. So you understand what we're doing, you just don't feel comfortable with it? Okay. So what goes into 5z to the 4th, 30z cubed, and 45z squared? 5z squared. Okay, so I write the 5z squared that I divided by out front. What is 5z to the 4th divided by 5z squared? Just z squared. 30z cubed divided by 5z squared. And 45z squared divided by 5z squared. 9. Okay. What multiplies to 9 and adds to 6? What? 3 and 2 multiplied to 9? Oh, yeah. 3 and 3. So I could write it like this, or since I have 2 of the same thing, I can write it with the squared. Okay, questions there? Okay, so another way I've taught you to factor before was factoring by grouping, and that was the one where you had the 2 sets of parentheses, and then we had to like find out what each set had in common. That was when we were doing trinomials. This time I have polynomials with 4 terms. So I'm going to break them into 2 sets, and then see what each set has in common. What does the first set have in common? Z squared. So what do I get in the first set when I divide? Z plus 5. And what can I take out of the second set? So I write what I divided by out front, and then what's negative 4z divided by negative 4? Negative 20 divided by negative 4? Positive 5. Okay, so notice they're the same. So that means I've done it right, first of all, that they're the same. So then what I do is I take my 2 outside pieces and I put them together. So I'm going to have z squared minus 4, and then z plus 5 at the end. Okay, and then notice I can factor this one more because it's a difference of squares. What's the square root of 4? Yes, we do. It's what? That was it. It was one more step. I'm sorry. Okay. Number 5, I start off by putting them in the 2 groups. What can I take out of my first group? What's 3y cubed divided by y squared? Y squared divided by y squared? What can I take out of my second group? So then I get 3y plus no, 1. Anything divided by itself is always 1. Okay. So notice the stuff inside the parentheses is the same again. Okay. So this one, do I split up?
No.
Why not?
I don't want to.
It's more than just because you don't want to.
It's really no.
It's really no. It's because this has a plus in the middle. You can only do it when it's a minus.
So when it has a minus, you have to do it?
Yeah.
So
Okay?
you have to write it plus and minus?
Yeah.
If it's minus.
Mm-hmm.
I thought we did it on that one because it's square root of 4.
Well, that too.
What was the rest of the 3 then?
The square root of 3.
Really, we have to do that?
Well, we don't on this one. I don't think you actually have problems like that where it's not a perfect square and a minus. Any other questions?